Okay, so we're looking at matrices today, and we're just looking at how they display information in this chapter. And you do just get a few little questions we saw yesterday on that. So here it says, the table opposite shows 3 types of membership at a local gym. The number of males, females enrolled in each class. Construct a matrix to display this information in a table. So you simply just have to draw a matrix. So we just do we're going to do a 2 by 3, and you would just simply, all you have to do is type it into a matrix as such. Okay, so, and things that you have to look at is obviously the rows are males and females, and the columns were the type of fitness class or something that they did. Okay, really important that you think about when your questions what they are, because sometimes you forget about that. So when you're working something out, you might just do a mathematical operation, but you might have no idea what you just did. So think about what the rows are, what the columns, and it might help you answer it. Okay, so we can sometimes get a network diagram. So a network diagram is like what you see there, where you've got, they call them vertex, so the points, and then you've got the lines in between. Sometimes they ask you to draw a matrix up displaying this information. So if there's a path connecting between the two, it's often you put a number 1. If there's no connection between them, you put a 0. So if we're going to set this up, so when you have a network diagram, you will generally have a square matrix. So you've got the 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so you look at town 1 over there. If there was a path, sometimes you see a path where it circles back to itself. So say, for example, you had town A or something, and it looks like that you may have that situation, but we don't. So between 1 and 1, it's 0. Between 1 and 2, there's 1 path. Between 1 and 3, there's no direct path. And between 1 and 4, there's 1. And then you just do the same. Between 2 and 1, there's a path. Between 2 and 2, there's no. So there's no looping there. Between 2 and 3, there's 1. And 2 and 4, there's also 1. And so on. We just keep going between all of them. And the last one, between 4 and 1, there is 4 and 2, and 0 and 0. So there would be setting up a matrix for that situation. So what we're saying is, these are the points. Sorry, can you see how we've got? Sometimes they're towns. They might get letters. So when you have, because we've got 4 of them, we will have a 4 by 4 matrix. So can you see I'm putting the labels along here, 1, 2, 3, 4. That's labeling those towns, okay? 1, 2, 3, 4. So what I'm saying is, if there's a path between, see how there's a path between 1 and 2? Yeah? If there's a connection, we're saying there's 1 connection, and that's why between 1 and 2 we put a 1. Okay, and it also happens between 2 and 1. It's the same road, but it's there, isn't it? So 2 and 1 as well. It's the same thing. Yeah. Okay, so looking at this one, it says a store has an outlet A, B, and C. The outlet sells dresses, jackets, and skirts made by the fashion house Oki or something. The table below lists the number of Oki dresses, jackets, and skirts currently held at each outlet. Okay, the matrix that shows the total number of Oki dresses, jackets, and skirts in each size at the 3 outlets is given by. So what you've got to do is you sort of just got to interpret. So you've got size, just look for one. So if we've got size 10, and they're saying that you've got 2 dresses at size 10. So if you look at outlet at size 10, there's 2 dresses there, and so that's good. So that piece of information is okay. So we've got to test all the other things. So they're saying there's one jacket in a size 10. Now, is that correct? I can't see any jackets in the size 10. So I'm going to get rid of this first answer. So let's just look across size 10. We want to see, size 10, we want to see, because they're doing size 10 across the top, I'm going to say, and we've got dresses, jackets, and skirts. I want to see there's 2 dresses, there's 0 jackets, and there's 3 skirts in size 10. So let's have a look. Is there only one option with that? Yeah, and that is B. Okay, so here it says the diagram below is the tracks directly linking these 4 towns or national parks. The shortest time it takes to walk between the camping site. Oh, this is a network question, sorry. Okay, the shortest time it takes to walk between the camping sites along each of the tracks is also shown. The matrix that could represent this this information is. So what, as I was saying, if we were setting this up, we'd first put all the points in, okay? So they've done it in alphabetical order, so we'll do the same. So they had P, Q, R, and S. So P, Q, and you can see the same pattern down. So I'm going to look at P and I'll just work out the first line. So between P and R is 50. So I'm going to see a 50 there. Between P and Q, I have a 20. Between P and S, it's 40. And between P and P, there's nothing. So have a look. Is there any one that says that, only says that across the top? There's 2 options, isn't there? There's B. Oh yeah, that one's around the wrong way, isn't it? So it's only E, so we're done. So here's another one. A small city is divided into 4 regions, north, eastern, south, and west. The number of adult males and the number of adult females living in each region in 2013 is shown in Matrix V. Write down the order of Matrix V. So here I'm just doing some practice short answers. So this one's easy. So remember, rows first. So there's 4 rows and there's 2 columns. How many adults lived in the male adults lived in the western region in 2013? So we go to male and western. So we write 1850. And in terms of the population of the city, what does the sum of the elements in the second column of Matrix V? So what they're saying there, if I add all these up, add all them up, what's that telling me? Yeah, the total amount of females in the population, yeah? In the population.